Last class we have seen what are the three layers of the earth or three realms of the earth. The outermost realm of the earth is the crust on which we live. So this crust of the earth is made up of different forces, is formed of different forces. The movements in the crust, the movements which are made by different forces of the earth are forming different relief features or land features which are landforms of the earth's crust. See, on the earth's crust we do not have all different types of, we do not have the plane surface, right? We have mountains, we have plains, we have plateaus, we have so many types of landforms. What is the reason why these landforms have formed? The reason is movements in the earth's crust. Last lesson we have seen about plate tectonics. So the movement in plates, is causing the formation of these landforms. Tectonics, if you remember, is construction or building. The Greek word tectonics is nothing but construction or building. So in this lesson we are going to see different landforms of the earth. So while we are saying the movements in the earth's crust are caused by two different forces. One is the internal forces of the earth, second one is the external forces of the earth. Internal forces means, see, like last lesson we have seen something like seismic waves. So seismic waves tell about the internal forces, internal energy of the earth. They do not say about what is external force, right? So we have two types of forces. One is endogenous forces and exogenous forces. Endogenous forces and exogenous forces. Endo means inside. Endo means inside. So endogenous forces are forces which are acting from inside of the earth. Forces which are acting from inside of the earth, that is plate tectonics. That is plate tectonics. So movement of plates inside will be causing different landforms, will be the cause of different landforms. We'll see what the type of landforms what we will be getting when the plates are moving, right? Exogenous. Exo means outside. Exo means outside. So external forces. External forces means like the sun, the temperature, excess temperature, the sunlight, the rainfall, the flowing water, the glaciers, ice. All these are external forces which are acting upon the crust. And these are the reason for formation of new landforms. See, for example, in the Ganga-Brahmaputra Valley, every year we have erosion, right? Every year we have erosion. So, with erosion we have formation of new plains. Right? So, that is an example of exogenous force. Endogenous force. Whenever we have a volcano or whenever we have an earthquake, the land will be breaking and you have a formation of a new landform, isn't it? There you have a formation of a new landform, obviously. So we have the formation of a new landform because of volcanoes which are coming from inside. It is not a force which is acting from outside, right? So volcano is something which is the energy which is coming from inside. That is why it is a endogenous force. Clear? Apart from this, we have some other movements known as orogenic movements and epirogenic movements. Orogenic movements and epirogenic movements. Orogenic movements means horizontal movements. Orogenic movements means horizontal movements. So it is formed by compressional forces or tensional forces. Compressional forces or tensional forces. This orogenic movements. Both are landform building movements only, but orogenic movements are compressional forces or tensional forces, and epirogenic movements, these are formed by subsidence or uplift. Either subsidence or uplift. So epirogenic movements, orogenic movements are horizontal movements, epirogenic movements are vertical movements, right? So both these movements also are responsible or also help in the formation of landforms. The basic difference between orogenic movements and epirogenic movements is these orogenic movements, they create folds and faults because they are horizontal movements. They create folds and faults. Folds and faults. They create folds and faults, and epirogenic movements are much slower than orogenic movements. Now let's see what is the outcome of all these epirogenic movements, orogenic movements. The outcome is what we have discussed earlier, that is the relief or the landform. Let's see the first landform, that is the mountains. Any landform which is rising abruptly, over an area, but is having sharp peaks, and summits, then that is known as a mountain. This is a mountain. Generally, mountains are of height which is more than 900 meters. Mountains are of height which is more than 900 meters, right? So this mountains may be a single mountain, a range of mountains, a chain of mountains. Suppose this range of mountains, you have parallel range of mountains, then that is known as a chain of mountains. A group of chain of mountains is known as a cordillera. Andes cordillera, right? Andes cordillera. It's a group of mountain chains, right? The only difference between a mountain and hill is generally hills will be having little rounded tops. And the altitude of the hill also is lesser than that of the mountain. The altitude of a hill is generally 600 meter high, 600 to 800 meter high, but if it is more than 900 meter high, then it is considered to be a mountain. We know what is the highest mountain in the world, highest mountain peak in the world, that is Mount Everest, which is lying in Nepal, 8,848 meter high, right? And one more interesting thing to know is 24% 24% of Earth's surface is mountains only. 24% of Earth's surface is mountains only. And 10% of Earth's population, 10% of people live on mountains. And one more interesting thing is, we know most of the rivers will be originating in the glaciers only, right? So most of the river water what we are getting is from the mountains only. So mountains, we cannot deny that mountains are of no use, right? On the basis of mode of formation and their characteristics, mountains are classified into different types. Fold mountains, block mountains, dissected mountains, volcanic mountains. Fold mountains, block mountains, dissected mountains and volcanic mountains. Let's see in detail about every mountain. So, the first one what we are going to see is fold mountains. In case of fold mountains, we have the rock strata being compressed. We have the rock strata. Strata is layer. Layers of rocks. Layers of rocks, when they get compressed, they get folded like this. They get folded like this. See, when we fold a paper, don't we get folds? Right? Don't we get folds? So that is how even rock strata, when it undergoes a lot of pressure. See, for example, you have two plates. Imagine two plates here. Two plates inside the earth, plate tectonics, and here rock strata is there. Rock strata is there. And when these plates are coming inside, these plates keep on moving constantly. So when these plates come together, this rock strata becomes like this, isn't it? So this is how we get folds inside. So we get one upper fold, we get one lower fold, right? So this upper fold is known as anticline, and this lower fold is known as syncline. The upper fold is known as anticline and this lower fold is known as syncline. Right? So this happens because of pressure inside, compressional forces. Right? So these anticlines, they form the peaks, they form the mountain peaks, and these synclines, they form the valleys. Right? One peak, another peak, and in between is the valley. Peak and valley. This is how the formation of a fold mountain will be. The best example of fold mountains is Himalayas, which is formed in the recent past. There are so many fold mountains, but the best example what we know is the Himalayas. So these fold mountains are again divided into two types. One is the young fold mountains and second one is the old fold mountains. One is the young fold mountains and second one is the old fold mountains. Young fold mountains is, which are formed in the recent past, not less than 20 to 30 million years ago, but old fold mountains which belong to the Hercynian period, more than 250 million years ago. The major differences between these young fold mountains and old fold mountains, in young fold mountains, they are formed in the recent past, so obviously they will be having sharp peaks and they are very tall. They are having sharp peaks and they are very tall. Old fold mountains, they will be having rounded peaks and they are comparatively shorter than the young fold mountains. The reason is very simple. These are subjected to weathering for a longer period of time. Weathering means the action of rain and sun for a longer period of time. That is why these are having rounded peaks and their size also is comparatively smaller than the young fold mountains. And moreover, these young fold mountains, they have rugged topography formed very recently, so they have rugged topography. Rugged means very harsh, very not very smooth. So they have rugged topography and these are having very smooth topographies, very smooth landforms. So because they are subjected to weathering for a longer period of time. Same reason. Suppose I have this chalk, if I am rubbing it for a long period, it becomes very smooth, right? So these old fold mountains are also the same, right? Examples for this young fold mountains, now only I told you, Himalayas are the best example of young fold mountains, Rockies, then here old fold mountains, Urals of Russia, then Aravalis of India. And still if we see some more differences between young fold and old fold mountains, young fold mountains are subjected to volcanic activities because the crust here is not proper. The crust here is not fully formed, right? Old fold mountains, the crust is good, fully formed. So here it is not subjected to volcanic activity and earthquakes. So here it is formed to folding and faulting of mountains and volcanic activity also, right? And here in old fold mountains, one other feature is we find monad rocks also. Monad rocks means abrupted raising of a mountain and something like it's flat up. So mostly we find this kind of monad rocks. So peaks are cut off. So this is one other feature of old fold mountains. Now let's see the formation of the great mighty Himalayas, right? Himalayas are formed by the collision of two major plates in India, in the world, that is the Eurasian plate and the Indian plate. The Eurasian plate the Indian plate. So previously we have discussed that there was only one supercontinent known as Pangaea, and this Pangaea was cut into different parts. And this Pangaea, the southern part of Pangaea, which was known as Gondwana, and the northern part, which is known as Angara or Laurasia. So they had a collision. At the Tethys Sea. So they had a collision there, and we had a fold. They had a very big fold. So it started slowly folding, and there were so many faults, and there were so many folds. So that happened to be the rise of the Himalayas. So this happened to be only a few million years ago. So that is why Himalayas are known as fold mountains, and these fold mountains, since they are not formed in a very olden period like Caledonian or Hessian period, they are termed to be as young fold mountains. They are termed to be as young fold mountains. So we can see the topography of Himalayas as rugged topography, and moreover the mountains, in the mountain region of the Himalayas we can see lot of volcanic activity and the earthquake activity taking place because the crust is unstable. So now let's discuss about the block mountain, the second type of mountain. Block mountain is also formed by tensile and compressional forces. Tensile and compressional forces. So this way and this way. Horizontal forces. Block mountain is formed by horizontal forces. Now if you see three plates, three parallel plates. If the two parallel plates are pushing, compressing. In the first case we have seen the rock strata becoming folds. In the first case we have seen the rock strata becoming folds. Here in this case, the block, the total plate is pushed up. So this plate totally is pushed up by the compressional forces. So it becomes like this. It becomes like this. The total block is pushed up. The total plate is pushed up and it becomes a block. So this becomes a block mountain. In the second case, there is in option B. In second case, they tend to move downwards also. The parallel faults, they tend to move this, they tend to compress this middle block, middle plate downwards also. So then it becomes like this. So then it tends to move in this way. So then this becomes a rift valley. Rift valley. We have two big rift valleys in the world, one in Africa and second one in Australia. So this becomes a rift valley. This becomes a block mountain in case when it is pushed up. In case when it is pushed down, this becomes a rift valley. All because of the tensile and compressional forces. So here we find a fault. Pushing this is a fault. This is a fault. In case of a block mountain. So here we find a fault. Okay, this is a fold and this is a fault. This is a fold and this is a fault. So this fault is pushing the middle part, parallel part up. So this becomes a block mountain. This block mountain is also known as a horst. And rift valley is also known as a graben. Block mountain is also known as a horst and rift valley is also known as a graben. So here we see few examples of block mountains and rift valley. So Vosges in Black Forest in Germany, the basin which is flowing in Vindhyas and Satpura, this is one block mountain in India. Next, coming to Rift Valley, that is the parallel fault which is going down Africa, near Syria, near Red Sea, then Australia, then near Damodar River in India. This is also an example of the Rift Valley. So now let's see the characteristics of block mountains. Block mountains are formed by three processes. One is faulting, uplifting and tilting. Faulting, uplifting and tilting. And most of the block mountains, they'll be having flat tops. Most of the block mountains, they'll be having flat tops. Right? Just like plateaus. Plateaus are very similar to block mountains. Why? Because plateaus are also raised forms and plateaus are also having flat tops. Abruptly raising and which are having flat tops. The main characteristics of a plateau is the same. But the difference between a plateau and a block mountain is that plateau is not formed from a fault, just abruptly raised, and these always run along the fault plane. So if there is a fault plane only, obviously we have a formation of a rift valley or a block mountain. And the next one what we are going to see is dissected mountain or residual mountain. Residual or dissected mountain. So here in residual or dissected mountains, just like what we have seen in case of old fold mountains. So in case of old fold mountains, what we have seen? So they will be having rounded peaks and they will be very smooth. In case of residual mountains also, we will be seeing the same. They will be having very rounded peaks, they will be having smooth topographies, right? The reason is, this is done because of erosion and weathering. All this is happened because of erosion and weathering, and that is why residue. Residue means what is remaining. What is remaining, or dissected means what is cut off, right? Dissected means what is cut off. So this is happening. This is happening because of erosion from lot of time. Erosion from lot of time. The Nilgiris in Tamil Nadu, Rajmahal Hills, Girnar Hills, Parasnath Hills in India, all these are an example of dissected mountains or residual mountains in India. And the next major landform what we are going to see is the plateau. Plateaus are also elevated lands. Elevated lands which are having flat tops. Right? Elevated lands which are having flat tops. And plateaus are termed as oldest relief or oldest landforms. So plateaus will be having lot of limestone, rocks, sandstone. Plateaus will be having large area on the top. Plateaus will be having very large area on the top, and the rock strata will be undulating. Means rough. It's wavy. It's not very smooth. But since it is having so many sandstones and limestones and all, the arrangement, the continuous wear and tear for these rocks, it will make the plateaus smooth. It will make the plateau smooth and sometimes tilted. And we have so many running streams. So these running streams, they make the plateau dissected. They cut the plateau. Right? So it is sometimes we do not see a whole flat, a whole broad base of the plateau. Very broad areas we do not see right as a plateau. Right? And since these plateaus are in tabular form, we call these as tablelands. And most of these plateaus are made up with sedimentary rocks or basaltic rocks. Basaltic rocks are nothing but igneous rocks, and sedimentary rocks, they are formed by sediments. Right? So most of these rocks are formed. For example, the Deccan Plateau of India is formed by basaltic rocks. On the basis of so many factors, plateaus are classified. So these plateaus are classified on the basis of their shape, origin, location. So let's see some classification of plateaus. The first classification of plateau is an intermontane plateau. And second one is volcanic plateau. Coming to the first one, intermontane plateau. Inter means in between. So in between what? Mountains. In between mountains, if a plateau is existing, then it is known as a intermontane plateau. Plateau is existing in between mountains, then this is known as a intermontane plateau. Plateau of Tibet, which is also known as the roof of the world, the highest plateau in the world, this is known as a intermontane plateau. Plateau of Tibet lies in between the peaks of the Himalayas, the ranges of the Himalayas, not the peaks, the ranges of the Himalayas. So this plateau is known as a intermontane plateau. Plateau of Bolivia is another example of intermontane plateau. Plateau of Anatolia is also an example of a intermontane plateau. And next one is of volcanic plateau. Volcanic plateau. In case of volcanic plateau, plateau is formed by eruption of volcano. So the lava will be flowing. After the eruption of volcano, lava will be flowing and the plateau will be forming like this. So this is how a plateau will be formed in case of a volcanic plateau. The Deccan Plateau of India is the best example of a volcanic plateau. So these layers, they form layer by layer, and that is known as a volcanic plateau. Right? The Siberian Plateau, the Parana Plateau in Argentina, the Columbia Plateau, all these are examples of volcanic plateau. Right? Apart from these, we have some other types of plateau. First one is tectonic plateau. Movement of tectonic plates. Difference of movement of tectonic plates. We have different types of plateaus being formed. Piedmont Plateau. One side we will be having a plain and one side we will be having a sea floor, sea bed. So that is also a type of plateau what will be seen. Continental Plateau. Continental Plateau means a plateau which is very far off from the sea floor, coast. And the next major landform what we are going to see is the plains. low-lying landforms. Just like we have seen, plateaus are high landforms, I mean high-lying and flat top, but plains are low-lying landforms. Majorly, the altitude of plains will be maximum 300 to 400 meter high. The altitude of plains will be 300 to 400 meter high. Most of the times the plains are smooth. Very few times they are undulating or rolling. Undulating or rolling. Right? And most of the plains are formed by deposition of alluvium which is brought down by the rivers. Most of the plains are formed by deposition of alluvium which is brought down by the rivers. Right? So now let's see the formation of plains and different types of plains. The first one is structural plains. Structural plains. So here in structural plains, most of the plains, these structural plains are formed by subsidence of land or upliftment of land. Subsidence of land or upliftment of land. See, for example, in case of Great Plains of the USA. Great Plains of the USA. USA. So this part forms the Great Plains. Great Plains of the USA, this part is formed by upliftment of land. Upliftment of land. So there was a slight upliftment of this land and this formed a plain. So this is a structural plain, either by upliftment or subsidence. In case of coastal plains of India, the Coromandel coast is there. In case of coastal plains of India, this part. The Coromandel coast, there is a slight subsidence. This is upliftment. And here, Coromandel coast, it is subsidence. So these are known as structural plains. Plains of Russia and central lowlands of Australia are also examples of subsidence. Not only the Coromandel coast, the opposite side, Malabar coast, is also an example of subsidence. So we see different types of landforms like depressions we see, lakes we see, seafloor we see. All these landforms are filled with sediments, filled with depositions. So these depositions, when it forms a plain, then that is known as a depositional plain. When it is filled with depositions, then that is known as a depositional plain. Maybe it is alluvium or maybe it is something else. Whatever the deposition may be, then when it forms a plain, it is known as a depositional plain. So generally this depositional work is done with the help of rivers or wind or sea. So this is glaciers. So this is how they are filled and that forms a plain. So this is how depositional plains are being formed. So these are different types of depositional plains. First one is the alluvial plains. Normally we see this type of plains only. So here in case of alluvial plains, the depositional work is done with the help of rivers. So rivers bring in all sediments and they deposit. So depositional work is done with the help of rivers. The best example of alluvial plains is Ganga Brahmaputra plain. Next one is drift plains. So in case of drift plains, the depositional work is done with the help of glaciers. In case of drift plains, the depositional work is done with the help of glaciers. Next one is lacustrine plains. The depositional work is done with the help of lakes. The depositional work is done with the help of lakes. Lowest plains. Depositional work is done with the help of wind. Right? Coastal plains. The depositional work is done with the help of sea waves. Right? Lava. The depositional work is done with the help of volcanoes. Deccan Plateau. Here, Deccan Plateau is the best example of a lava plateau, also known as a basalt plateau. So in this lesson we have covered what are the movements of the earth and what are the different types of landforms.